This is AP Calculus AB. We're in Notes section 2.5. This is part 3 of those notes, part 3 of 5. For this particular problem, we are looking at a table of values of the derivative, and we're going to try to figure out things that we would know about the original function based upon that. The table of values below represents values of the graph of the derivative h prime of x of a polynomial function. Now, the reason it tells us it's a polynomial is that tells us right away this is a continuous function. Super important. The zeros indicated in the table are the only zeros of the graph of h prime. So only zeros. Additionally, the graph of h of x is concave up when x is 3. I don't know how to use that yet, but I'm going to underline that because that's important. And if that's not good enough to make sure that we know that's important, I'm going to write it down. If we finish this problem and didn't use that fact, we have made a terrible error because they're not going to tell us that unless it's super important. Question 10. I'm supposed to use this table to answer questions 10 through 15. On what intervals is the function h increasing and decreasing? Give a reason for your answer. This table is h prime. I think you would agree that according to this table, h prime is positive here and here. So since there's no other zeros of this graph, h prime is positive here. It's going to be continually positive as we go to the left, because if it were to change to be negative, we'd have to have a zero at some place. So we can safely say that h prime of x is greater than 0, it means it's positive, on the interval from negative infinity to negative 2 non-inclusive. I stopped at negative 2 because at negative 2 it becomes 0, which is not positive. The conclusion that we can draw from this is that h of x is increasing on the interval from negative infinity to negative 2. On what intervals is the graph increasing? Let's find increasing and decreasing and give a reason. We have the reason and we have that it's increasing. H of x is going to be decreasing whenever h prime is less than 0, when it's negative. H prime, which is this table, is negative on this interval from negative 2 to 7, non-inclusive, and then from 7 to infinity. H prime of x is less than 0 on the interval from negative 2 to 7 in union with 7 to infinity. Therefore, h of x is decreasing. You could say on these intervals, or you could say the intervals again. Whatever toots your flute. Whatever floats your boat. Whatever tickles your thing that gets tickled, whatever that is. All right. Once again, as we continue, we got to remember this table here is for the derivative. These are slopes. If the slope's positive, it means the graph's going up. If the slope's negative, the graph's going down. 11. At what x values does the graph of h of x have a relative maximum? Justify your answer. Without even looking at my table, I know what the justification is. H prime of x, the derivative, has to change from positive to negative to get a relative maximum. And where does h prime change from positive to negative? It changes right here at x equals negative 2. It's positive on the left, it's negative on the right. So I could say h prime changes from positive to negative at x equals -2. My conclusion, therefore, h of x has a relative maximum at x equals -2. At what values does it have relative maximum? We set it here. Justify your answer. This is my justification right here. If you don't like the symbol plus or minus, you can say changes from positive to negative, and that's ultimately that's better to say positive or negative, but you know, I'm lazy. At what values does the graph of h of x have a relative minimum? Justify your answer. Well, I don't know the answer to this yet, but I do know this. H prime of x is going to have to change from negative to positive. Now, where does that happen? Looking at our table, it's positive, and then it's negative, and it never changes from negative to positive. It goes positive to negative, back to negative. So instead of me saying h prime changes from negative to positive at, I'm going to move this over and say h prime never changes from negative to positive. And I'll write this one out since I did in the last one. The conclusion, h of x does not have a relative minimum. To have a relative minimum, the graph has to change from decreasing to increasing, which means h prime has to change from negative to positive, and it doesn't happen anyplace. All right, 13. If h of 3 is 2, let's talk about the original function. What is the equation of the tangent line of the graph at x equals 3? So we want to know what's the equation of the tangent line, and we also want to know what the equation is of the normal line. So in order to do this, we have to have a point of tangency, which is also a point of normalcy, by the way. And we're given that point right here. It's 3, 2. To find the slope of tangency, that's what our table's for. When x is 3, the slope is -3. So to make sure that's clear, I'm going to write that down. This is asking for h prime of 3, and that's -3. So the tangent line is going to be y minus our y value equals the slope times the difference of x and our x value. To find the normal line, we take the same equation that we just used, but we use the negative reciprocal slope. So instead of a -3, it's a positive 1/3. Notice the similarity between these answers. A normal line and a tangent line at the same point of tangency, everything's the same, but these slopes are negative reciprocals of each other. 14. Find the tangent line approximation of h of 3.1. Is this approximation greater or less than the actual value? Give a reason for your answer. So let's just, first things first, let's find the tangent line. Find the tangent line approximation. So I'm going to take the tangent line, which is this right here, and if I want to find the tangent line approximation, I'm going to replace the x here with 3.1. I'm going to add 2 to both sides here. 3.1 minus 3 is 0.1. Negative 3 times 0.1 is negative 0.3. If I add 2 to that, I'm going to get 1.7. So to answer the question, h of 3.1 is approximately 1.7. So I think I got the first part answered. Find the tangent line approximation of h of 3.1. Did it. Is this approximation greater or less than the value of h of 3.1? Give a reason for your answer. Well, I don't know. How would I possibly know if this is a over approximation or under approximation? In other words, is 1.7 bigger than the actual y value or is it less than it? We would have to know the concavity of this graph to answer this. And although we don't know the concavity every place, we do know the concavity super close to 3.1, and that's right here. It says that h is concave up at x equals 3. Let me try to explain this to you, and then we'll write this down. This original explanation I'm going to give you, you wouldn't have to put on a test or a quiz, but you might want to put it in your notes. If the graph is concave up, so this is concave up, someplace on here is 3.1, and we have this tangent line. No matter where I draw this tangent line, it's going to always be under this graph. See if I can manipulate this. I can put this tangent line any place I want, and no matter what I do with it, it's always going to be underneath of this, which means any y value on this tangent line, with the exception of the point of tangency, is going to have to be less than a point on the curve, because the curve's always above it. If I had a curve that was concave down, and I had a tangent line, the tangent line would always be above it. So my approximation would always be an over approximation. So going back to this problem, hopefully that made sense. Is this approximation greater or less than the actual value of h 3.1? Well, it tells us that h is concave up at x equals 3. So h of x, is my reason, is concave up at x equals 3. At x equals 3. Therefore, the tangent line is below h of x. Therefore, it says, is the approximation. Therefore, h of 3.1, which is approximately 1.7, is, hold on a second, this is concave up? Yeah, this is, it's an under approximation. So just want to make sure I answer the question the way it's asked. Is this approximation greater or less? I'll say the approximation is less. Therefore, h of 3.1 equals 1.7 approximation is less than the actual value. All right, just one more time, I want to make sure that I answered this. Find the tangent line approximation. Okay, we found the tangent line approximation right here, and it wouldn't be crazy to say the tangent line approximation is this. Is this approximation greater or less? H of 3.1 equals 1.7 approximation is less than the actual value. Give a reason. The reason is h of x is concave up, which means the tangent line is below h of x. Good enough. This will definitely be on a test or a quiz. You're going to be asked to find a tangent line approximation and then asked to give a reason, whether you know if it's an over or under approximation. 100% certain that that's going to happen on a test or a quiz. 15, find the values of each of the following. Let me bring this table down here so we can see this. What's the limit as x approaches negative infinity of h of x? In other words, as you go left, is it going to be going up or is it going to be going down? Well, here's what we know. To the left of negative 2, we know the graph is increasing. So we know it looks something like this. When it gets to negative 2, it's a relative maximum, and then it starts going down. And then when we get here, we have another horizontal tangent, which we're not exactly sure what that's going to look like for this to happen, because then it just continues to go down again. So this is a little bit foreign to us. This area here, we'll figure this out later what that means. But we do know for sure it's increasing here, it's decreasing again. So what's happening to h? And once again, this is h of x. It's an approximation of it. As we go left forever, looks like our graph is going down. So it's approaching negative infinity. As we go right forever, it looks like it's also going down. So this is also going to negative infinity. All right, that concludes this example. And this was us examining a table of values using the derivative.